Hello guys, welcome to this channel, and if you're new to this channel, subscribe for more videos like this. So this is chemistry or science paper 2. So the question is saying table 15.1 shows the electronic configuration of 5 elements A, B, C, D and E. The letters are not the symbols of the elements. So on the right hand side here we have the electron configuration of these elements on the left hand side. So now for the first one we have element A, which is having 2, element B 2, 1. Now one thing that you need to know is that when writing the electron configuration, the number of electrons in the outermost shell determines the group where an element is. An example, A, it just have 2 electrons, meaning it is found in group 2. Then as for element B, it has 2, 1, meaning the number of electrons in the outermost shell, they are just 1, or just 1, meaning B is found in group 1. Similarly to element C, it has 2, 8, 1. It has 1 electron in the outermost shell, meaning it is also found in group 1. Then when it comes to D, it has 2, 8, 7, meaning the number of electrons in the outermost shell, they are 7, and it is found, this element D is found in group 7. Then the last one, which is E, it has 2, 8, 8. So we have 8 electrons in the outermost shell. Therefore, E is found in group 8, which is a noble gas or inert gases. Now let's try to look at how to determine the period of elements, or the period in which elements are found. So let's start with A. So as for A, you just have 2 electrons. If we write the electronic structure of A, we can say we are going to have something like this, where A is going to be at the center, then 2 electrons in the orbitals, or the orbital. So now as you can see here, we just have 1 orbital, meaning A is found in period 1. In short, if you want to know the period where an element is found or is, just count the number of shells that an element has. So let's try to look at B. So B, it has 2, 1. If we draw the electronic structure of B, we are going to have something like this one, where the first shell is going to contain 2 electrons. Then the next shell is going to contain only 1 electron. So to determine the period in which B is found, we are going to count the number of shells. So we have shell 1, shell 2. Therefore, B is found in period 2. Then as for C, it has 2, 8, 1. So if we draw the electronic structure of C, the first one we are going to have 2 electrons. Then the next one we are going to have 8 electrons. Then the last one we are going to have 1 electron. So the number of electrons in the outermost shell, they determine the group. And then the number of shells that an element has determines the period in which an element is found. So C is found in period 3, because here we have how many shells? We have 3 shells. We have 1, 2, 3. So C is found in period 3 because it has 3 shells. Then as for D, so as for element D, it has 2, 8, 7. So now, let me not draw the electronic structure. So here I'll be just counting the number of shells by saying this one is going to be shell 1, this one is going to be shell 2, and this one is going to be shell 3. Meaning D, it has 3 shells. Therefore, element D is found in period 3. Then let's come to E. E, it has 2, 8, 8. So we have shell 1, shell 2, shell 3. Even element E is found in period 3, but in group 8. So that is how we determine the periods and the groups. So now let's try to answer the questions. So they are saying, use the information in the table 15.1 to answer parts A to D. So we have the first question, which is saying, explain why the elements B and C are in the same group of the periodic table. So why are elements B and C in the same periodic table? Try to write the electronic configuration of B and C. We can say B is having 2, 1. Then C is also having 2, 8, 1. So now as you can see, B is having 1 electron in the outermost shell. Even C is having 1 electron in the outermost shell. So therefore, B and C, they are found in group 1. Now they are saying, explain why the elements B and C are in the same group of the periodic table. So we need to explain. So we are going to say, because both elements have 1 electron in their outermost shell. Because both elements, they have 1 electron in their outermost shell. So that's the answer. Then as for B, state the letter of an element that forms an ion with a charge of -1. Now usually, when it comes to the periodic table, group 1 up to group 3, they are called metals. Group 1 up to group 3, they are called metals. And usually metals, they lose electrons so that they become a cation. An example that I can give you is element B. Of course, B is not the actual symbol of the element, so we are just going to say element B. So element B, it has 2, 1, meaning it is found in group what? 1. I'm saying the elements from group 1 up to group 3, they are known as metals. And metals, they usually lose electrons to form a cation. Meaning B is found in group 1. Therefore, for it to be stable, it is going to lose this 1 electron. So once it loses 1 electron, it is going to become a cation by forming a positive charge on top here. Why is it going to form a positive charge? Because it is losing 1 electron. Okay? So if it is losing 2 electrons, an example, if you have 2, 8, 2, meaning this element is found in group 2. And therefore, it is going to lose 2 electrons for it to become stable. Once it loses 2 electrons, it is going to become a cation. Suppose if this element, which is having the electron configuration of 2, 8, 2 is Y, meaning it is going to form a positive 2 here. Why are we putting 2? Because it is losing 2 electrons here. So when an element is losing 1 electron, just indicates a plus. And when it is losing 2 electrons, just say +2, and so on. Now, elements from group 4 up to group 8, they are known as nonmetals, or they are nonmetals. Now, for them to become stable, they usually gain electrons from group 1 up to group 3 elements. Outermost shell electrons must be 8, except for helium, which has 2 electrons in the outermost shell. Only helium. Then other elements like chlorine, for it to be stable, it needs to have 8 electrons in its outermost shell electrons. Then apart from this one, if you have 2, 7, meaning this element, for it to become stable, it needs just 1 electron for it to become stable. Now, when nonmetals gains electrons, they become an ion by forming a negative charge. So, if we have something like 2, 8, 5, how many electrons are remaining for this element to become stable? So this element needs 3 electrons for it to become stable, because when you add 3 plus 5, you are going to get what? 8. So this element needs 3 electrons for it to become stable. Now suppose the element which is having the electron configuration of 2, 8, 5 is Y. And we are saying when an element gains electrons, it is going to form an ion, which is a negative charge. So this one needs how many electrons? It needs 3 electrons, meaning we are going to say it is going to form -3. Then when an element needs only 1 electron, it is going to form -1. So we can say if we have something like 2, 8, 7, meaning this element needs only one electron for it to become stable. So if this element was y, we can say y to the power -1, meaning for this y to become stable, it needs only one electron. So as you can see from the table 15.1, we have D, which is having 2,8, 7. And this element only needs one electron for it to become what? Stable. So it is going to gain one electron and form -1. So the answer here, we are just going to say D. Now, if the question was saying state the letter of an element that forms an ion with a charge of -2. So if we had -2 here, meaning from table 15.1 would have been given something like 2,8,6, because for this one to become stable, it needs how many electrons? 2 electrons, meaning it is going to form -2. So let's move on to the next one. So the next one is saying explain why elements A and D are in different periods of the periodic table. So I'm from talking about the periods. How can you determine the periods of the elements? So suppose you have 2,8. So this element is found in which period? It is found in period 2. So if you want to know the periods, just count the number of shells. So we can just say shell 1, shell 2. So this one is found in period 2. So the number of shells that an element has determines the period in which an element belongs. Then the number of electrons in the outermost shell determines the period in which an element is found. So let's try to look at A and D. The reason why A and D are found in different periods. Looking at the electron configuration of A, we can say A just have 2. Then when it comes to D, it has 2,8, 7. So A is found in which period? It is found in period 1 of the periodic table. Then when it comes to D, it is found in period what? 1, 2, 3. So D is found in period 3. Now, the question here is saying explain why elements A and D are in different periods of the periodic table. So we are going to say this is because they have different number of shells or orbitals. This is because they have different number of shells or orbitals. If you see carefully here, when it comes to A just have 1 shell. Then when it comes to D, it has 3 shells. That's the reason why we are saying they have different number of shells. So any M number of shells, they are going to be found in the same period. An example is C, D, and E. All these elements, they are found in the same period of the periodic table because they have the same number of shells. B is saying, state the letter of an element that is a noble gas. So a noble gas is just an element with 8 electrons in its outermost shell. So as you can see here, which element is having 8 electrons in the outermost shell? It's just E. I'm going to say the answer is going to be E. The next question. So the next question is coming from the extraction of metals, specifically the extraction of iron. So it is saying iron is extracted from the ore, which is the ametite. So ametite is just the iron 3 oxide, which is Fe2O3. That's the iron 3 oxide. So iron is extracted from the ore ametite in the blast furnace. So we have the waste gases here. An example of the waste gas here that we can have carbon dioxide. And sometimes in an exam, they can also ask you to give them the use of the waste gases. So the use of the waste gas here, we can just say, this carbon dioxide, it is used in making fire extinguishers. Then apart from making fire extinguishers, we can say, carbon dioxide is used in the natural process of photosynthesis. Then apart from that one, we also have the raw materials here which are plugged in so that we have iron and so on. So the first raw material, that we have here, we have coke, which is pure carbon. Then apart from coke, which is the pure carbon, we also have the iron ore, which is the iron 3 oxide, which is ametite. Sometimes they can also use magnetite. Then the last one is going to be limestone, which is calcium carbonate. Then apart from that one, we have the air entering here. We also have slag, which is calcium silicate. And the last one, which is the molten iron. So molten iron is usually under the slag. Okay. Question A, it is saying the coke reacts with the oxygen in the air to form carbon dioxide. So that is the first process during the extraction of iron from ametite. So carbon reacts with oxygen to form carbon dioxide. Then after that, carbon dioxide is going to be reacted with more coke to form carbon monoxide. So I'm saying the next process is going to be carbon dioxide reacted with more coke to produce carbon monoxide. That's the first process. Now here they are saying, which is Roman numeral number 1, explain why carbon monoxide is formed higher in the blast furnace. So now as you can see here, I'm from saying the next step is going to be this one. When carbon reacts with oxygen to form carbon dioxide, the next step is going to be carbon dioxide plus carbon, which is the coke or pure carbon, to form carbon monoxide. Now, this one is going to happen at higher temperature. So we are going to say this is because when there is high temperature, carbon monoxide is formed when carbon dioxide reacts with more coke. So I'm saying this is because at high temperature, carbon dioxide reacts with more coke to form carbon monoxide. So that one is the answer. In Roman numeral number 2, write an equation for the reduction of ametite, which is the iron 3 oxide, by carbon monoxide. So we have iron 3 oxide, which is Fe2O3, being reacted with carbon monoxide. So carbon monoxide here is just act as a reducing agent. Then carbon, which is the pure carbon, or we can call it as coke, it acts as a catalyst. That is one thing that you need to know. So when iron 3 oxide reacts with carbon monoxide, what is going to be produced here is just iron, which is going to be in molten, or we can say liquid, then plus carbon dioxide. Okay. So that is how we write the equation for the reduction of iron 3 oxide. Just know that when iron 3 oxide has been reduced, what is going to be formed? Iron, which is going to be in molten, or we can say liquid state, and also carbon dioxide is going to be produced. So that's the answer for Roman numeral number 2. The next question, which is B, Roman numeral number 1. Limestone decomposes to form two products, one of which is calcium oxide. Name the other product. So let me just try to write all the equations which are involved during the extraction of iron. So the first one, we have this one here, where we can say carbon, which is coke, is going to be reacted with oxygen to produce carbon dioxide. Then the next step, we are going to find that carbon dioxide is going to react with more coke to form carbon monoxide. Then after that, the iron 3 oxide is going to be reacted with carbon monoxide to produce iron, which is going to be in the molten state, plus carbon dioxide. Then the next one, they are saying calcium carbonate decomposes to form calcium oxide. Now they are saying we need to name the other product which is going to be produced also. So calcium carbonate decomposes, it is going to form calcium oxide. Then the last product is going to be carbon dioxide, which is CO2. So we can say the next product, or the product which is going to be formed apart from calcium oxide, is going to be carbon dioxide. Then as for Roman numeral number 2, calcium oxide reacts with silicon 4 oxide, an acidic impurity in the ion O, to form slag. So slag is just calcium silicate. So here they are asking us to write an equation for this reaction. So we have calcium oxide being reacted with silicon 4 oxide. And what is going to be formed here is going to be calcium silicate, which is calcium silicate. So that is how we write the equation for the reaction of calcium oxide and calcium silicate. Now, why are we writing calcium silicate like this? Here they are saying silicon 4 oxide. Oxygen, it has the valence of 2, and here silicon, it has the valence of what? 4. So if we write silicon having the valence of 4 here, and oxygen having the valence of 2 here, the valences, they are going to be exchanged. As a result, here we are going to have silicon with a 2, then or 4. Then after that, you are going to find the common denominator here, which is 2. Even here 2. 2 into 2, we are going to get 1, which is silicon. Then 2 into 4, we are going to get 2. As a result, we are going to have something like this one, which is this one here. So that is where this one is coming from. Then as for Roman numeral number 3, explain why the molten ion and the molten slag form 2 layers and why molten ion is lower layer. So we are going to say this is because ion is denser than the slag, which is the calcium silicate. So here the slag is just called the calcium silicate, and the use of slag is the first one you can say is used in building roads or road construction. Then apart from road construction, we can also say in the manufacturing of cement and so on. Roman numeral number 4, suggest why the molten ion does not react with the air. This one, let's try to look at this one here. So at the base or below the slag, ion is going to be reacted with oxygen to form iron oxide. So now this iron oxide, it is going to be formed when ion reacts with oxygen. Meaning, when a metal forms an oxide, that oxide, it is going to be a barrier. For example, if you have aluminium oxide, the oxide is going to be a barrier. That one is going to stop other reactions. So we are going to say this is because molten ion forms iron oxide, which is unreactive, or that one prevents iron oxide to react with other elements, or to prevent iron oxide to react with air. So that's the answer. The next question is coming from organic chemistry, and it is saying figure 9.1 shows molecules of ethane, ethene, and ethanol. Question A, Roman numeral number 1. State and explain which of these compounds are hydrocarbons. So, looking at this question here, when they talk about hydrocarbons, these organic compounds which are made up of hydrogen atoms and carbon atoms only. We see ethane and ethene. These are made up of hydrogen atoms and carbon atoms only. But when it comes to ethanol, it has the inclusion of an oxygen atom. Therefore, we are going to say ethane and ethene. Now, why are we saying ethene and ethane? So we need to explain here. This is because ethane and ethene only contain hydrogen and oxygen atoms. That's the answer. Let us for Roman numeral number 2. State and explain which one of the 3 compounds named above is unsaturated compound. So from the answer that we have wrote on Roman numeral number 1, we need to choose which one is an unsaturated hydrocarbon. So usually the unsaturated hydrocarbons, they are called alkenes. And an example of an alkene here is just ethene. So ethene is an alkene. So we are going to say ethene. Now why are we saying ethene? Usually unsaturated hydrocarbons, which are alkenes, they have a double bond in between carbon atoms. So the double bond here is this one here. That's a double bond. And saturated hydrocarbons, they are called alkanes. And usually alkanes, they don't have a double bond. They just have a single bond in between carbon atoms. Explanation, we can say this is because ethene has a double bond. Now, sometimes in an exam, they can also ask you to write the general molecular formula of all alkanes. So let me start with alkanes. An example of an alkane is ethane. So usually alkanes, they have the general molecular formula of CnH2n plus 2, where n is going to represent the number of carbon atoms. So how many carbon atoms do we have here? So 2. So you need to plug 2 here and also 2 here. If you want to know the chemical formula of ethane, then let's come to ethene. So ethene is an alkene. So usually an alkene or alkenes, they have the general molecular formula of CnH2n. That's all. Where n also is going to represent the number of carbon atoms. So this one here, how many carbon atoms do we have here? So we have 2 carbon atoms. So we can say C2, then H. If we plug in 2 here, we are going to say 2 multiplied by 2, then we are going to get 4. So this is how we write the chemical formula of ethene. The next question. State one use of ethanol. So ethanol is an alcohol. And I've forgotten to give you the general molecular formula of alcohols. So the general molecular formula of alcohols is just CnH2n plus 1, then we can say hydroxide, which is OH. Now here they are asking us one use of ethanol. Ethanol is an alcohol. So we can say it is used in alcohol beverages. Then apart from alcohol beverages, we can say it is used as a solvent in thermometers, like a laboratory thermometer. We can also say it is used as a fuel. So alcohol is also used as a fuel. Then Roman numeral number 2. In industry, ethanol is made in a chemical reaction involving ethene. Name the substance that reacts with ethene to produce ethanol. So during the production of ethanol, you can produce ethanol in 2 ways. You can produce ethanol by fermentation. You can also produce ethanol by reacting it with steam. So now this one is in an industrial preparation of ethanol. So here we can say ethene is going to be reacted with what? Steam. So you can say steam or water. It's up to you. So usually this process is called steaming reaction, or you can say hydration reaction. That's the answer. Then the last one, which is Roman numeral number 3. The reaction in B, Roman numeral number 2, needs a catalyst. That's the meaning of the term catalyst. So a catalyst is any substance which speeds up the rate of a chemical reaction without being changed at the end of the reaction. So I'm saying a catalyst is any substance which speeds up the rate of a chemical reaction without being changed at the end of the reaction. So that was the last one. So if you're new to this channel, subscribe for more videos like this. Thanks for watching. Peace.